Hi, in this Let's Create series we're creating a Crossy Road clone like this. In the last episode we implemented the particle effect on death. In this episode we'll ensure that we tidy up our procedurally generated level as we progress, so we don't keep around the terrain forever. Let's get started. To outline the problem, here I am playing the game. I'm not particularly good, but I can get beyond level 100 fairly consistently. However, now that I'm here, we really don't need those terrain objects back at the start. We've needlessly got the objects in memory, and we're animating the vehicle movements every frame. A lot of wasted compute. So we need a way of tidying these up. In the real Crossy Road, if you don't progress quick enough, you're caught by the flying eagle, or whatever it is. This forces you to progress forwards, which means they can heavily cull objects away, knowing you'll never be able to go back. We haven't implemented that mechanic yet, but we'll implement the culling as if we have. In our GameManager.cs script, we are storing all the information about each terrain segment in the obstacles list. However, we only store the terrain height and the location of the obstacles. We don't have a reference to the game object, so we can't deactivate or destroy it. So we need to update that. Let's extend the tuple to also include a game object reference called obj. Then down in this spawn obstacle method, we need to update what we add to the list for the road and grass terrain. To the road, we'll store in the third position road.gameObject to get the game object associated with the road. And similarly for the grass, we'll use grass.gameObject to store a reference to the object. Whilst we're here, we'll also add in a bit of code to rename the terrain objects just so it'll make it easier for us to see if this is working correctly. We can change the name of the object using road.gameObject.name. This will set to start with the spawn location so we know what position it is, and then we'll just add on -road so we know what type it is. We can do exactly the same thing for the grass game object when we spawn that, changing the suffix to grass. Now we've got our reference, we want to destroy the old objects. We can do this in our update method in the same place where we're spawning new terrain. We have this while loop that ensures we always have 20 terrain ahead of us, but it only adds terrain when we've moved forwards. So we can hook into this to remove the old objects we no longer need also. We're spawning new objects, spawn distance ahead of us, which I originally set to 20. Let's remove objects 20 behind us then to keep things symmetrical. So the index of the object we want to destroy will be at characterpos.y minus spawn distance. I've put this into a variable called oldIndex. Now we can check if the old index is greater than or equal to 0. If it's not, then it points back to our starting area and there's nothing procedurally generated to remove there. If it is greater than 0, then there's a possibility we've already removed it, so we should check that. If it's been destroyed, the game object reference at the obstacle at position old index will be null. So if it isn't, we need to remove it. To remove it, we simply call destroy on the object given at the old index in the obstacles list. We're not in a rush to remove the object, we don't need to use destroy immediate. As this should be off screen already, we can happily wait for Unity to destroy it in its own time. And that should be it. Now, as we move around, we should be creating obstacles 20 ahead of us and destroying them 20 behind us. Let's check that out. If we start the game and make sure the terrain holder is open, you can see that we've got all of our terrain types nicely labelled. As I progress forward, we're creating more, and hopefully when I reach position 21, we'll start removing the old ones. Yes, that looks like it's worked. You can see number 0 has been removed from the hierarchy. As I keep going, we're happily removing the old ones, so we only ever have 40 terrain objects at any one time. That'll be much more performant. However, what happens now when I head backwards? The tension mounts. You can see that as I've got back 20 spaces now, you can see there's no terrain here anymore. We did destroy it after all. So either in our game we implement some mechanism that stops the player coming back this far, or we have to implement a way to put the terrain back. Since the point of the game is to progress forwards, let's implement a limiting factor. I don't have an eagle model to do the getting picked up by a bird bit, so instead let's just make ourselves die if we come back too far for now. Let's start back in the character.cs script. We want to be able to call the character's death effect from the game manager when we go back too far. So let's refactor out the kill logic from onCollisionEnter method into a new one. What I'm going to do is remove everything from hiding the character to telling the game manager we've collided from within the if statement. I'm going to put all of this within a new public void called kill. Importantly, this is public so it can be called from the game manager. The only change I've made here is to remove the vector3 collision point variable and instead pass that as an argument, because when we call this manually there isn't a collision, so we can't keep that bit in. In the onCollisionEnter, we can now simply call this kill method with the collision.getContact0.point, which was our point we wanted the death effect to originate from. Now we've got a reusable kill method that we can call from the game manager, so we can jump over there to add the logic in. We want the character to die if we go back too far, so just like we've done for the terrain cleanup, we can trigger this from our update method. Just after the code that checks if we need to spawn new obstacles, we'll add a check if we've gone back too far. We know what the furthest we've gone is because we're storing that in the score variable, so we can simply check if the character pos.y value is less than the score minus 10. If it is, we've gone too far back and we should trigger the kill method. We don't actually have a variable that stores the character script, but we can simply get it again with character.getComponent of type character, and then we call the kill method. I'll note at this point this is the second time we've called getComponent to get this. We also call it to do the reset event. It's still a rare event, so it's not going to be a performance bottleneck, but now we're doing it multiple times, it's a key indicator that perhaps we should do this once at the start into a variable. I'll leave that up to you. The only thing we need to do is pass in the position we want the particle effect to spawn from. You can only ever go back too far by naturally going backwards, so we'll have the particles emit from a bit above the character. The position will thus be the character.transform.position to get the position of the character, plus a new vector3 to offset this a bit. We want the y to be 0.2 so it's above the ground, and z to be 0.5 so it's half a tile forwards. That's it. We can head back into Unity now to check this out. Let's first check that going backwards into the start area doesn't kill us. We should be allowed to go backwards. Now we need to progress forwards far enough that we can go back. So I'll just go to 15. Now we can turn around and head back. Hopefully, when we take 10 steps, we'll just spontaneously explode into a bunch of cubes. Excellent. That's it for this episode. I've now given you the core game mechanic to Crossy Road. You can take it from here. Have a go at implementing the train and the water terrain yourself and making a UI. Please let me know in the comments if you'd like more episodes in this series. I hope you found this tutorial useful in some way, and a big thank you to all my Patreon supporters. As ever, the full code is on GitHub and linked in the description below. See you next time.